All right. So my lesson is all about implementing EA standards and profiles. MIT 506, MIT 2A Enterprise Architecture. First is we will discuss about the area of conversation. The first one is service-oriented architectures and enterprise architecture standards. The next one is reference models and EA profiles. So let's talk about the service-oriented architectures and EA standards. In service-oriented architectures and EA standards, the enterprise architecture standards are the outcome of many years of international academic study and agreement among industry experts on repeatable patterns that can be repeated. Regardless of the many frameworks, methods, approaches, goods, services, and activities that any business, no matter how large or little, may use, they have been specifically created to be totally customized to and applied by them. These methods are used in the development of the enterprise architecture standards. Investigate and evaluate what works to consistently recognize the distinguishing characteristics employed by top businesses or the leading process. Identify current and common patterns which form the basis of the enterprise standards. Construct reference content that raise the bar in the fields of enterprise modeling, enterprise engineering, and enterprise architecture for reuse and replication. Add performance and value boosters to your extension includes special features taken from the recognized best practices and leading practices. In what is service-oriented architectures? Through a communication protocol over a network, application components deliver services to the other components in a software design approach called service-oriented architecture or what we call SOA. Its tenets are unaffected by suppliers and other technologies. In a service-oriented architecture, many services interact with one another by exchanging data or coordinating an action between multiple services. SOA-based services are flexible, interchangeable, separate from but linked to an application through clearly specified interfaces. The first one is do smaller, more specific business operations like obtain customer address or larger ones like process payment. The second one is are not tightly connected to a new or old application. The third one is possess the ability to carry out the actions, duties, and activities of at least one business process. And the fourth one is can be coupled in a way known as service orchestration to carry out a number of tasks. Now let's talk about the state SOA backplane. A services registry rules business analytics, routing or addressing, quality of service, communication, and development tools for security, management, and adapters. Shared common infrastructure for lifecycle management. The next one is service providers and consumers. The majority of the time, entities, or we say people and organizations, perform services and offer capabilities. A service consumer is a person with needs who uses a service. Service conditions and planning design standards. Application modules created using the SOA are intended to follow service specifications to guarantee that the service satisfies the necessary condition. Standards for planning and design are provided. There must be modules in the service. By putting together a group of little, straightforward parts that function as a whole, this gives flexibility to address complicated challenges. The first one is that the services must be made to be loosely connected. And it's important to define and document service interfaces. What about in standards for EA and for service-oriented architectures? In order for another developer to identify and utilize the service, developers must enter interface metadata or use tools to produce interface metadata that provides an explicit service contract. All access to a service must be made through its exposed interface, and everything required for the service to perform its functionality must be supplied to it when it is invoked. Service boundary explicitness. The service must be accessible without requiring any hidden assumptions. Collaboration between business analysts and architects is required to guarantee that business processes are distinct, that service applicants are capable of achieving business requirements, that are adequately defined and documented changes and needs. In service condition and planning design standards, we have the distribution-friendly modules are required. Running on different computers and devices is possible for service components. Through the use of message-based network communication, people run time. Services are typically spread out over multiple physical locations. A service must be used by multiple consumers. SOA operations are inherently distributed applications. To create a service, the service provider is accountable, contracting with and negotiating with each service consumer. The state's ICC SOA must display service contracts. Information about the service is shared through the services registry. The next one is the module interfaces need to be searchable. Service components can run on different machines and communicate with one another in real time by sending messages over a network. The names of services to accurately describe the work in what is known as the real-world effect. Services must be called according to their function. Typically, services correspond to business tasks. In the name of the service must encompass the key features of its practical application. In other words, it must describe what the service achieves in commercial terms, rather than how it functions. The terms verify zip code and verify accurate address, for instance, are descriptions of services based on or named after the effects that occur in real life and are simple for business and technical employees to understand. And lastly, the name must not include any information regarding the services, implementations, underpinning information system, provider company or agency, or any operationally specifics. We have also service specification. A thorough explanation of the service's impact in the actual world. a list and a brief description of each action, and a list and a quick description of the main data and entities involved in interacting with the service through its actions must all be included in the services. There must be no implementation specific information or dependencies in any part of the description. Instead of referencing specific databases or systems when describing the real-world impacts, the description must focus on the services' effects on the business. The fourth one is there must be swappable service modules. Another module that provides the same service can take the place of the service module without causing any problems for modules that depended on the old module. In order to do this, the module that implements the service is separated from the interface design. This separates the implementation, which is the service provider module scope and data, from the interface metadata. A copy of the interface metadata is accessible to other developers separately from the code that implements the provider component. This makes it possible for the consumer developer to use the service without having a copy of the provider software module. It is also enables multiple development teams to create interchangeable provider modules, which the consumer and the provider can use different programming languages, application servers, and operating systems. The next one is the service provider modules must be shareable. In order to support a variety of business operations, services must be built and deployed such that they can be called repeatedly by different applications. Multiple agencies, departments, or separate agencies and entities can use the same service. This service condition ensures each provider module is in an SOA application can be invoked successively by disparate. The developers can write different consumer application modules that use the same service as long as they conform to the conditions specified in the interface contract. The next topic is reference models and EA profiles. In the typical approach to EA, there are 6 reference models. The first one is Performance Reference Model, the PRM. The next one is Business Reference Model, or the BRM. We have also Data Reference Model, the DRM, Application Reference Model, ARM, Infrastructure Reference Model, IRM, and lastly, we have Security Reference Model, SRM. These reference models are taxonomies that provide standardized categorization for strategic business and technology models and information. This supports analysis and reporting across agencies, FAs, EAs, and each of the documentation domains. Each reference model will have its own taxonomy, methods, touchpoints, and use cases. The associated meta model will illustrate the relationship between the reference models, with the use case providing examples of how each reference model can be applied. First, let's talk about the performance reference model. The strategy sub-architecture view of the overall EA is supported by architectural analysis and reporting by the performance reference model. The PRM is both a taxonomy and a standard method for performance measurement, as it provides for a common approach to performance and outcome measurements. The PRM allows agencies to better manage the business of government at a strategic level by providing a means for using the EA to measure the success of investments and their impact on strategic outcomes. The PRM accomplishment, this goes by establishing a common language to describe the outcomes and measures used to achieve strategic objectives from copied business services, such as vision and support. The PRM shows the linkage between internal business components and the achievement of business and customer-centric outputs and outcomes. Most importantly, the PLM helps to support planning and decision-making based on the comparative determinations of which programs and services are more efficient and effective. The three major of the PRM are as follows. First, improved performance data should be produced to aid in daily and strategic decision-making. The second one is to improve alignment and clearly explain how inputs contribute to outputs to establish a direct line of sight to the desired outcomes. And the third one is find chances for performance improvement that go beyond the limits and typical organizational structures. The next one is the reference model for business. In the business services sub-architecture view of the overall EA, the business reference model facilitates architectural analysis and reporting. The BRM offers a functional view of organizations and their lines of business, including mission and support business services, as opposed to a structural organization chart view. The BRM describes an organized organization called a taxonomy of common shared mission and support services areas. Instead of true-type single organization view, the BRM therefore promotes the intra- and inter-agency collaboration and serves as the underlying foundation for sector and federal-wide shared services and strategies. The next one is Data Reference Model or the DRM. What information is available for sharing and reusing, and what are the information gaps needing correction? These are the two basic questions that the Data Reference Model focuses on as its supporting foundation for the broader EA. The DRM decided to provide a flexible common framework for effective sharing of information across organizational boundaries, increase integration and reuse opportunities, and support semantic interoperability while respecting security, privacy, and appropriate use of that information. The DRM provides a standard means by which data may be described and categorized and shared. These are reflected within each of the three DRM standardization areas are: first is describe the data. It enables the standard description of data, facilitating its discovery and sharing. In the context for data, it helps in data discovery by using a method for classifying data according to taxonomies. The definition of authoritative data assets within a community of interest is also made possible. The third one, we have the data exchange. Supports ad hoc requests for data access, such as a query of a data asset, and fixed, recurring transactions between parties for data sharing, enabled by the possibilities offered by the standards area for both data context and data description. The next one is Application Reference Model. The Application Reference Model or the ARM provides architectural analysis and reporting in the applications sub-architecture view of the overall EA. The ARM is a component-driven taxonomy that classifies the standards and technologies associated to systems and applications that support and enable the delivery of service components and capabilities. The next one is Infrastructure Reference Model. In the host infrastructure sub-architectural view of the overall EA, the Infrastructure Reference Model or the IRM allows architectural analysis and reporting in order to support and enable the delivery of voice, data, video, and mobile service components and capabilities. The IRM is a component-driven taxonomy that groups standards and technologies linked to networks and the cloud. The next one is the security reference model. In all of the sub-architectural views of the overall EA, the security reference model or the SRM provides architectural analysis and reporting. The first one is to give organizations a roadmap for combining IT security and privacy with EA. The second one is identify security and privacy requirements by means of a method. And the third one is promotes incorporating security and privacy into company activities and procedures. And lastly, the organization system development lifecycle processes and the NIST risk management framework to guarantee that pertinent security and privacy criteria are integrated and continuous monitoring is put in place. Thank you for listening.